When it comes to specific cosmic shapes or patterns, especially those that are unnaturally symmetrical, geometrically precise, or look unnervingly artificial, the human mind can see them in ways that provoke anxiety. We might experience fear or tension when seeing or even thinking about certain shapes or structure in space. A fear that stems from a combination of psychological, static, and existential factors. There's something about geometrically perfect shapes like circles or rings that can bring out fear, partly because they're too orderly. While most objects in nature like trees or mountains are irregular and asymmetrical, planets are often geometrically perfect spheres. This perfect symmetry is a departure from the chaotic and imperfect patterns we typically see in nature, and for some, it can feel almost unnatural or too orderly. A planet's roundness is a product of gravitational forces acting on it, and while this is a natural process, it can trigger discomfort in those with a fear of symmetry, because a perfect sphere is an idealized form that doesn't naturally occur in most human experience. Unlike the irregular shapes of mountains, oceans, or even other celestial bodies like asteroids, a planet's roundness with no edges or corners represents unusual order, which might feel unnerving. It can also imply a lack of direction or escape, and seen as a closed loop or an unbreakable cycle with no room for deviation or freedom. The perfect spherical nature of a planet with uniform boundaries can feel limiting and oppressing. It could be a reminder of how we're bound to the Earth, a world in which everything is interconnected but trapped in its own orbit. The apparently uniform and precise rings of planets like Saturn could bring a similar sense of strangeness, because they seem so perfectly symmetrical and ordered. Saturn's rings are seemingly a finely crafted set of concentric bands of ice and rock particles, which might trigger anxiety and discomfort due to their geometric perfection. Not to mention the sheer magnitude and scale of Saturn's rings, stretching over 175,000 miles in diameter. Also the sheer size of Saturn itself, with a diameter about 72,400 miles, or 116,500 kilometers, the second largest planets in our solar system. The vastness of the rings can feel disorienting, as if the mind struggles to process the scale and detail of what it's seeing. They resemble something artificial or man-made, leading to eerie sensations, trigger an unsettling feeling, because they might be too perfectly constructed for nature, and therefore out of place in the chaotic random universe. The rings of Saturn are remnants of ancient moons that were torn apart by the planet's gravity, which is why they could symbolize decay or the inevitability of destruction. This could manifest as a fear that even the most enduring cosmic structures are ultimately subject to impermanence, that everything, no matter how perfect, will eventually be destroyed. In this sense, the rings may trigger fears about the fate of the Earth and the eventual end of the solar system or the universe itself. Back many years ago, as telescopes were scanning some uncharted territories of the cosmos, an unexpected discovery wasn't out of the realm of possibility. What wasn't expected was the discovery of some odd and spooky objects right away. Astronomers have never seen anything like it before, so they couldn't put it into any category of known astronomical objects. Also, due to the giant pile of data, it was expected for discoveries to be made using machine learning. But after reviewing the rest of the data using the old-fashioned way, the team was able to find even more of those similar round blobs. They dubbed these mysterious objects ORC, short for Odd Radio Circle. The first assumption was that these objects might be some sort of an artifact, maybe as a result of a software error. That assumption was dismissed as soon as ORCs got confirmed using other radio telescopes. It could also be some kind of instrument flaw, but that turned out not to be the case. They weren't supernova remnants, or rings of radio emission, or gravitational lensing effect. They're completely invisible in X-ray, optical, or infrared wavelengths, only in radio waves. Researchers explored all the possibilities and concluded that these mysterious ghosts are like anything we've ever seen before. It turns out that these faintly luminous, ginormous ghostly structures are shock waves shaped by powerful winds emanating from the cores of galaxies. There's a galaxy at the center of each ORC. These galaxies aren't typical. Rather, they're rare and very interesting ones. They've experienced or are going through a phase called starbursting, a period marked by intense star formation. ORCs may be generated by outflows emanating from the very center of these galaxies. Some interesting questions remain unanswered. What's the lifespan of an ORC before it diminishes to a very dim level? How likely is it that such phenomenon happens to these rare galaxies? Does it happen universally in all starbursting galaxies? Or are specific conditions necessary? Is a starbursting a prerequisite? Galaxies, the huge collection of planets, stars, gas, dust, and dark matter bound together by gravity, come in a variety of shapes and sizes. They're classified into different categories based on their appearance and structure, with the most common being spiral, elliptical, and irregular galaxies, and rare, lenticular, and ring galaxies. There's this isolated, rare, and fascinating ring galaxy called Hoag's object. It has this almost perfect circular ring of stars, surrounding a dark, starless central region. There's more star-forming gas mass in the ring region than the entire Milky Way galaxy. What sets this galaxy apart is not just its ring-like shape, but the near-perfect symmetry of the ring itself and the lack of a clear explanation for its formation. While most ring galaxies are thought to form after a galactic interaction or a catastrophic galactic collision, where one galaxy passes through another and the gravitational forces cause a ring of stars to form, Hoag's object doesn't seem to have undergone such an event, since it's so structured and even. Astronomers have struggled to determine why it has such a perfectly defined structure. The central region is largely devoid of stars, creating a dark, almost black void in the middle. The surrounding ring, however, is filled with young blue stars and gas, which suggests active star formation. This combination of a bright ring and dark center makes Hoag's object a visually striking and unusual galaxy, unlike most others in the universe. It's an incredibly rare galaxy. Less than 0.1% of all known galaxies have this distinctive ring galaxy structure. It's one of only a handful of known ring galaxies, and at the same time, it's one of the most symmetrical examples discovered. What's maybe even more odd is this interesting coincidence. Despite the extreme rarity of ring galaxies, another ring galaxy seems to be visible within the dark region in the middle. We don't know how this galaxy formed. There are many interesting theories, but there's no generally accepted one yet. The overall proposal is that it could be the result of a long-term stable process, or that the galaxy could have been formed by an unusual set of conditions. Whatever the case, its unique structure makes it a cosmic anomaly. Hoag's object's form embodies the very essence of Cosmophobia. Its eerie, symmetrical ring and the vast, uncharted black emptiness in its center taps into a fear of the unknown. While there are possible explanations for its unique shape, its impressive appearance is truly extraordinary. Its mysterious form, particularly the contrast between the bright ring and the dark void at its center, can evoke fear and discomfort, emphasizing the vast, unknown forces at play in the universe. The contrast between the bright, active stars in the ring and the utter emptiness at the center could evoke a sense of isolation, as if the galaxy itself is a self-contained entity, detached from the familiar laws of physics and cosmology. The black void region is particularly unnerving. In a sense, it represents the unknown, a terrifying emptiness in the middle of a vibrant and otherwise ordered structure. These central darkness represent more than just the absence of stars. It can symbolize an unknowable, uncaring void in the universe, where the usual rules no longer apply. Hoag's object could also potentially serve as a home to a super advanced alien civilization that's so large, so populated, and so advanced that they've consumed a good chunk of the galaxy as energy, using advanced technology to extract energy from stars and other cosmic resources. Hence, the void in the middle. The idea of an alien civilization living in this area, with technology far beyond our comprehension, though unlikely, or very unlikely, adds another layer of dread to this fascinating galaxy. The universe is so gigantic that our minds struggle to grasp it. The numbers involved, light years, astronomical units, or parsecs, are meaningless in practical terms, making the distances feel infinite and unreachable. It's not just that the cosmos is big, but that it's so large we can't even measure it meaningfully in human terms. A galaxy is an enormous, mind-bogglingly large collection of stars, gas, dust, and dark matter, all bound together by gravity. Earth's diameter is around 7,900 miles or 12,700 kilometers. The Sun has a diameter of about 865,000 miles or 1.4 million kilometers. Our planet is a speck or a dot compared to a star. Our Milky Way galaxy is roughly 100,000 light years across. A light year is about 5.88 trillion miles, or 9.46 trillion kilometers, an unfathomable size. Milky Way has around 200 billion to 400 billion stars, not to mention the rest of the planets, nebulae, black holes, gas, dark matter, and the rest. Now imagine all of that, plus the insane distances between stars in a galaxy, with stars like the Sun being millions of miles apart from each other. The distance from the Earth to the Sun is 1 astronomical unit, 93 million miles or around 150 million kilometers. But the distances between stars in our galaxy can easily range from a few light years to several thousand light years apart. Zooming out from the galaxy Hercules A, one of the brightest galaxies in the entire universe. In its center lies one of the most powerful supermassive black holes ever discovered, 2.5 billion times the mass of our Sun, and over 1,000 times more massive than the black hole at the center of our Milky Way. Out of its core emerges an incredible force, an intense quasar, jets of ultra-high energy particles accelerating close to the speed of light, lighting up the surrounding space like a cosmic lighthouse. They're beacons of extreme energy and power, sending waves of radiation that can be seen across unimaginable distances. These bipolar jets are 1.5 million light-years long. They dwarf the galaxy itself, and what's even scarier is the fact that they're optically invisible to our eyes. They dominate the landscape of the galaxy and space around it. The energy released from these jets is so huge that they make Hercules A one of the brightest extragalactic radio sources in the entire sky. Zooming out to galaxy groups, galaxy collections bound together by gravity, containing anywhere from a couple of galaxies to a few dozen. But even the smallest galaxy groups are as large as millions of light years across. The local galaxy group includes the Milky Way, the Andromeda Galaxy, and around 54 other smaller galaxies, and is about 10 million light years across. Zooming out to galaxy clusters, much larger structures than galaxy groups, containing hundreds to thousands of galaxies, many million light years across. The popular galaxy cluster called Virgo has about 1,300 galaxies and spreads roughly 1 million light years. Zooming out to even larger structures, galaxy superclusters, vast network of galaxy clusters bound together by gravity. A supercluster can contain hundreds of galaxy clusters, and its total size can be a couple of 100 million light years across. The Laniakea supercluster, which is the supercluster our Milky Way is part of, is around 520 million light years across, containing around 100,000 galaxies, grouped into multiple galaxy clusters. Zooming out to cosmic filaments, the largest scale structures in the universe, massive strings of galaxies and galaxy clusters, stretch up to hundreds of millions of light years. Filaments are the bones of the cosmic web, linking superclusters together and forming a vast interconnected network across the universe. These filaments are typically about 100 million light years long, though they can extend even farther. Zooming out to the entire observable universe, we see a sphere 93 billion light years in diameter, and this is only the observable part, the part from which light has had enough time to travel through space and reach us. The jump from familiar objects like planets and stars to vast galaxies, galaxy groups, and beyond triggers a sense of insignificance. It's not just that these things are distant or hard to picture, it's that they're so mind-bogglingly massive that they seem to go far beyond the limits of human understanding. When thinking about a single galaxy, like our Milky Way, with its hundreds of billions of stars, or even larger superclusters that span millions of light years, the enormity of these structures makes us, our planet, and even our sun seem like trivial parts of a much larger cosmic story. It's as if the universe exists on a scale that completely dwarfs us, and that realization can cause anxiety or discomfort. The more we zoom out, the sheer vastness becomes more and more hard to process. The numbers and distances lose their meaning altogether. This could provoke existential discomfort. The more we think about it, the more we might begin to feel the weight of these insane sizes bearing down on us. The universe seems endless, almost indifferent to our existence, and that realization can bring a sense of fragility or vulnerability. When light travels across huge distances in space, it can be bent and distorted by the gravitational pull of massive objects like galaxies, black holes, or star clusters. This bending effect causes distant objects to appear stretched, distorted, or even duplicated in space. In some cases, this distortion can make a faraway star, galaxy, or quasar appear as multiple images, like a cosmic mirage, or cause arcs of light to surround the lensing object in strange and mesmerizing shapes. This phenomenon can also magnify the appearance of distant objects, making them look much larger and brighter than they would otherwise. This phenomenon, known as gravitational lensing, is caused by the mass of objects that distort the fabric of space-time itself and bend the path of light that travels through space. One of the most striking manifestations of gravitational lensing are Einstein rings. An Einstein ring occurs when an observer, the lensing object, and the distant background object are perfectly aligned along a straight line. This perfect alignment causes the light from distant object to be bent symmetrically around the lensing object, creating a ring-like appearance. The resulting ring is a highly distorted image of the background object, often appearing as a complete or partial circle. These rings are a rare and remarkable consequence of gravitational lensing. Despite being extraordinary and fascinating cosmic phenomena, the very idea that light, which has traveled across billions of years, can be bent by an unseen force to form these perfect symmetrical structures, this odd view of a perfectly formed and gigantic ring of light could be scary and terrifying. There's something unsettling about how these rings reveal the immense gravitational forces at work, forces that warp space-time and manipulate the very fabric of reality. The vastness of the universe, the idea of such far-reaching forces shaping what we see, and the surreal, almost unnatural symmetry of the rings can provoke a sense of dread. The fact that these rings appear only under very specific conditions, requiring near-perfect alignment, and gravitational forces strong enough to bend light and the very fabric of space-time, highlights the mysterious and sometimes eerie nature of space. The universe is gigantic. Its scale is incomprehensible from a human perspective. Even our closest neighboring star system, Alpha Centauri, is 4.37 light-years, or 25.7 trillion miles, or 41.4 trillion kilometers away. To really grasp just how huge the distances are, think about not just the enormous distances within our own Milky Way galaxy, the interstellar space, but also the staggering distances between galaxies, the intergalactic space. When we think about these cosmic distances, even the fastest human-made spacecraft seem extremely slow, and the idea of traveling to the nearest major galaxy becomes meaningless. The closest large galaxy to the Milky Way is Andromeda Galaxy, located around 2.5 million light-years away. A light-year is the distance that light, with a speed of almost 300,000 kilometers per second, travels in 1 year, which is roughly about 6 trillion miles, or 9.5 trillion kilometers. So when we say Andromeda is 2.5 million light-years away, we're talking about 14.7 quintillion miles, or around 23.5 quintillion kilometers. This is such an unfathomable distance that it defies human intuition, and that's just our neighboring galaxy. Now let's imagine you start this hopelessly impossible journey from Earth, traveling toward Andromeda. Even if you could somehow travel at the speed of light, it would take you 2.5 million years to reach your destination. Nothing travels faster than light, yet, even at that incredible speed, it would take over 2.5 million years to cross the distance separating us from our closest galactic neighbor. From a human perspective, reaching a destination like that within a human lifetime is beyond the realm of possibility. Even with future technology that could approach a significant fraction of the speed of light, we still run into the problem of time. To travel to Andromeda in a human lifetime, With the fastest spacecraft ever built, it would take over 60,000 years to reach just the outer edges of our galaxy, let alone Andromeda. And that's assuming we could somehow maintain this speed over such a long journey. The sheer size of these distances is mind-boggling. No matter how much technology advances, the distances involved in intergalactic travel are so vast that they exist outside the scope of human experience, making them difficult to fathom. Imagine you've left the Milky Way galaxy and are heading toward Andromeda with a highly advanced spaceship traveling nearly at the speed of light. You might expect to feel the passage of time, like moving toward a distant destination, watching it slowly grow larger on the horizon. But that just won't happen. No matter how fast you go, in your entire lifetime, assuming it's around 100 years, or even 200, or let's say 500 years, you won't notice any change in how far away Andromeda is. No matter how much time you spend traveling, you just wouldn't see it get any closer. You could be traveling at 99.99% the speed of light, and you'd still be moving so slowly in comparison to the vastness of space that for practical purposes, you'd never perceive any change in your proximity to the galaxy during your entire life. After 50 or 100 years of travel, you'd still be just a tiny fraction closer to Andromeda, with the difference too small to even notice. This sense of immensity is what makes the universe so terrifying. These distances, so far beyond the scale of human experience, aren't just difficult to comprehend. They can also feel alienating. Our minds are not built to grasp these kinds of timescales or distances. Our lives are finite, brief, measured in decades, maybe a century or so, and yet the universe dwarfs our lifetimes in any way, shape, or form. The distances are so vast that they almost erase our place in space-time. There's a profound and unsettling dread that comes with this realization. No matter how far you travel, the universe remains unchanged, inflexible, and immovable. Our individual lives are too short, too small to ever make a difference or leave a mark at such an expanse. The thought of traveling for centuries or even millennia without ever seeing any change in the scenery triggers deep existential anxiety. The notion of never arriving at your destination, of traveling forever through emptiness of intergalactic space, triggers a sense of futility or pointlessness. This fear comes from the knowledge that human technology, however advanced it becomes, can never truly overcome the sheer scale of the universe. Even with the speed of light, the universe will always be just too far away, too massive to conquer in any meaningful way. In the face of such distances, the universe seems infinite, and maybe that's the scariest thing of all. The vastness is not just physical, it's a psychological abyss. Now there are 2 trillion galaxies scattered throughout the observable universe. Each one of these galaxies is an enormous collection of stars, planets, nebulae, black holes, and countless other cosmic phenomena. The observable universe spans about 93 billion light years. Thinking about this scale can trigger feelings of being lost or insignificant, as if nothing we do can leave any lasting impact on such an immense universe. The numbers are so vast, the distances are so unimaginable, it makes our existence feel utterly insignificant. This fear of insignificance is at the core of Cosmophobia, the fear of the vast, unknowable universe and our place within it. The deeper we think about the endless expanse of galaxies, the more we may feel like we're just drifting in an uncaring, infinite void. One of the most terrifying regions of the universe are cosmic voids, huge empty regions of space where the density of galaxies, stars, and even dark matter is much lower than in the surrounding areas. These voids can be enormous, with sizes ranging from tens of millions of light years across up to hundreds of millions of light years in diameter. Again, 1 light year being roughly 6 trillion miles, or 9.5 trillion kilometers. The largest known void, the Buddha's void, expands over 330 million light years. It would take light traveling at the fastest speed allowed in the universe 330 million years to travel across Buddha's void. These voids are not just empty patches, they're regions with only a few isolated galaxies, and some may contain almost none at all. Around them, galaxies, stars, and other matter are clustered together into the filaments and walls of the cosmic web, making these voids appear as huge, dark chasms in the fabric of the universe. In fact, voids can make up as much as 80% of the observable universe in terms of volume, even though they contain a fraction of the universe's matter. The terrifying scale of these cosmic voids and their emptiness can evoke a sense of overwhelming isolation. When we think about space voids, it's not just about the emptiness, but about the overwhelming, incomprehensible scale of that emptiness. The universe is full of stars, galaxies, and planets, but in a void, there's nothing but an absence of these things stretching across unimaginable distances. The emptiness seems so profound and seemingly infinite that it feels almost like a physical presence. Imagine standing in the middle of a vast, open plain with no horizon in sight, just a vast expanse of nothingness. The thought that there are regions like this that can be so utterly devoid of matter, so impossibly empty, where nothing exists for hundreds of millions of light years at a time, feels unnatural and terrifying. It's an indication of the vastness and loneliness of the universe. It's not just an absence of stars or planets, it's an absence of everything. The void feels like a place where even the laws of physics are thin, where gravity has less influence, and where time and space stretch out in endless isolation. They're not just empty in the conventional sense, they're almost alien in their scale. The voids are places that seemingly stretch on forever. Imagining the vast emptiness of the universe in the grand scheme can be terrifying. The diameter of our solar system, considering the Earth cloud as its outer boundary, is estimated to be around 200,000 astronomical units, which translate into roughly 3 light years across. This entire system could vanish without a trace if it were put in such boundless emptiness. There's no meaning or purpose in these voids, just a stark reality of their limitless isolation. Cosmic voids are permanent and unchanging feature of the universe, vast and dark oceans of nothingness. The silence and emptiness of these cosmic voids can feel suffocating, as though we're surrounded by an infinite quietness, with no one to hear or see us. Space, in its purest sense, is not a welcoming place. It's a place where your survival would be under constant threat from the environment around you. Traveling through space might feel like a never-ending struggle to stay alive, facing all sorts of unpredictable dangers at every turn. The universe is filled with a staggering number of cosmic disasters, events that are incomprehensibly violent and completely indifferent to the existence of life. These disasters unfold on such a massive scale, often with such suddenness and unpredictability, that they underscore a fundamental truth. The universe simply doesn't care about human life. It's a vast, uncaring space where disasters happen, and life has close to nothing influence or control over the grand cosmic forces at play. Destructive radiations are all around within galaxies that can be catastrophic to life. Some areas of space, such as the Milky Way's galactic core, have far higher concentrations of cosmic radiation, making them fatal to unprotected life. The universe is also full of asteroids and comets, some of which are in collision courses with planets and moons. A large asteroid strike can instantly vaporize entire regions, generating firestorms, tsunamis, and global climate shifts. The probability of a future catastrophic collision is far from negligible. When a massive star exhausts its nuclear fuel and collapses under its own gravity, it causes a dramatic explosion that releases an enormous amount of energy, a supernova. In addition to releasing intense radiation, a supernova can scatter heavy elements across the galaxy, which is crucial for the formation of new stars and planets. This is the universe's way of recycling matter, and it's not concerned with the survival of any life on its path. A more extreme version of a supernova is hypernova, triggered by the collapse of a star with mass greater than 30 times that of the Sun. A nearby hypernova could decimate life on Earth without warning, flooding our planet in fatal radiation. Gamma-ray bursts, or GRBs, are one of the most extreme and dangerous events in the universe. These bursts, which last anywhere from milliseconds to several minutes, can release more energy than the Sun will generate over its roughly 10 billion years lifespan. GRBs are caused by kilonova, supernova, and hypernova explosions, also neutron star mergers, magnetar activities, and the processes around supermassive black holes in active galaxies. If a GRB were to occur relatively close to Earth, within a few thousand light years, it could potentially destroy all forms of life or any biological activity on the planet by stripping away the atmosphere and expose its entire surface to radiation. Cosmic events are often completely random, happening without any pattern we can detect in advance. Since the speed of light is finite, by the time we notice one of these events unfolding, it's already too late to react. These events can travel across space and reach Earth in a matter of seconds or minutes, making it impossible for us to prepare. The power of these disasters, their unpredictability, are reminders of how fragile our existence is. Space doesn't care about us. It's a vast, unforgiving wilderness full of cosmic disasters, all of which are indifferent to the existence of life. The universe's ability to destroy or alter life is limitless, random, and relentless. Space is a place of extreme temperatures. In the coldest parts of the universe, far from any stars or galaxies, temperatures can dip to absolute zero, where all molecular motion halts. Close to a star, temperatures can soar into millions of degrees. The core of the Sun reaches temperatures around 15 million degrees Celsius. If you were to get close enough to one of these extremes, either by traveling near a star or falling into a black hole, you would be incinerated or frozen instantaneously. Space also harbors some of the most extreme pressures imaginable. The pressure near the core of a star can be billions of times greater than Earth's surface pressure. The extreme objects in space, like neutron stars, represent some of the most intense and mind-boggling phenomena in the universe. The pressure around these objects stretches the limits of human comprehension. Neutron stars are cosmic crushers. They're remnant cores of massive stars that have exploded in supernova. After the explosion, the core's matter becomes incredibly compacted. ending up in an extremely dense object. A neutron star with a mass roughly 1.5 times that of the Sun would be compressed into a sphere just about the size of the Manhattan. This means that a teaspoon of neutron star matter would weigh around 10 billion tons on Earth. The gravity near a neutron star is so intense that it warps space-time itself. Anyone standing close to a neutron star would be crushed by pressure immediately. Every atom in their body would be pulled apart by the sheer force of the star's gravity. Imagining this crushing weight of gravity and the extreme conditions would feel utterly suffocating. The most extreme type of a neutron star, the most powerful magnet in existence, is a magnetar, an ultra-powerful magnetic field. The magnetic field of a magnetar can be a quadrillion times stronger than the Earth's. In fact, it's so intense that it can crush atoms, warp the structure of matter, and tear apart electrons in atoms. Anything within its magnetic field's reach would experience unimaginable pressure, as if the very fabric of matter were being twisted and distorted, and the laws of physics themselves were being pushed to their breaking point. It's very hard to imagine the sheer pressure around objects like this. It could evoke fear, anxiety, and existential dread. The extreme pressure close to these objects isn't just physical, but also psychological. When we think about such extreme objects, our minds are dealing not just with the scale of the universe, but with our own vulnerability within it. The magnitude of these forces, gravity, magnetism, pressure, pushes us into a place where our physical and mental limits are completely overwhelmed. The scale of the pressure around these objects is so enormous that simply thinking about it could trigger anxiety. The idea that something so powerful could exist beyond our comprehension, something so crushing, so violent, and so far beyond our control, might trigger a sense of overwhelming helplessness. We are absolutely powerless in the face of such extreme forces. These objects represent a realm where the concepts of pressure and force goes far beyond anything we can experience on Earth. Thinking about these extreme objects might also evoke feelings of being trapped or crushed under the weight of something much greater than ourselves. It's a reminder of how fragile we are in a totally violent and indifferent cosmos. Education and understanding are effective ways of coping with cosmophobia. The vastness of the universe can seem overwhelming, but gaining knowledge about it can help reduce anxiety that often comes with it. The more we learn about the cosmos, the more we come to realize that while the space is insanely large, it's not an immediate threat to our daily lives. Understanding the size and scale of space, the nature of outer space objects, and the actual risks involved can help individuals contextualize their fears. The universe is so large that even the closest stars are light years away, making direct threats from other celestial bodies extremely unlikely in our lifetime. When we think of how small Earth is in comparison to other planets, stars, nebulae, quasars, and the rest, it can feel as though we're totally powerless or insignificant in the grand scheme of things. However, understanding the scale of the universe can also be reassuring. While the cosmos is huge, the distances between objects in space are so large that most of them have no direct impact on us. Learning about the size of the universe and how far away stars and galaxies are can help reduce the fear of something we feel is beyond our control. Even though supernova explosions or neutron stars are fascinating and dangerous phenomena, they're located far, far away from Earth, so an immediate threat from such objects is highly improbable. The most catastrophic events in space, like asteroid impacts or local GRBs, are rare, and the likelihood of them affecting Earth in the near future is incredibly small. Even the possibility of an asteroid colliding with our planet is a remote concern, and there are global efforts in place to track and monitor near-Earth objects to prevent any potential threats. For those who fear existential risks, it's reassuring to know that scientists are actively studying this phenomena and developing strategies for early detection and mitigation. The more people understand the odds of such events occurring, the more they can reassure themselves that the universe, while full of dangers, is not an immediate danger to their lives. Space exploration itself can play a crucial role in mitigating fear. The achievements of space agencies like NASA haven't only advanced human knowledge, but also demonstrated that the unknown can be explored, understood, and in some cases managed. The realization that the vast majority of cosmic dangers are extremely unlikely, combined with the technologies and efforts to protect our planet, can significantly calm anxiety. Most importantly, learning to find meaning and connection in our daily lives can help us embrace the wonders of the universe rather than be consumed by how small, fragile, and powerless we are within the enormous and wondrous cosmos.